Hello. This is the recording for A Star Maths for this third lecture. There's an empty classroom at the moment, hence this is a recording for YouTube right now. I'm hoping the luck of people in this means that everyone has passed their exam, but I thought I'd better record just in case there are some of you out there who want to watch the YouTube recording back. So what we're going to do today, we are going to carry on with algebra, just looking at a couple of the more complicated topics to do with algebra. So we're going to focus on factorizing quadratics and simultaneous equations in particular. These are two topics which come right at the end normally of a foundation paper. So some of the trickiest things you will come across from an algebra perspective. They can be hard skills to um, master, but we'll focus first on the factorizing quadratics. Now, quadratics are basically equations which include the form x squared. So in general, a quadratic is written in the form a x squared plus bx plus c, and a, b, and c are numbers within this, so they all represent numbers. So it's always like this. Now, the A is not really relevant when we deal with foundation maths, because in foundation maths, A will always equal 1. So therefore, whenever you see a quadratic equation, it'll be x squared, and then maybe it could be, say, like plus 3x plus 5 for B, and C will represent numbers. Okay. Welcome, Alia. I'm glad you've made it along, because currently I'm doing a YouTube recording, but I've been talking to myself, so nice to have someone to
Suleiman
make it
complete,
along
say
listening.
you're not Alia.
Sorry?
Don't Suleiman come. Say you're not Alia.
I'm not Elia.
So because he used his account sister is Suleiman. So you have
Oh,
one-to-one.
Suleiman. Okay, no problem at all. Well, welcome, Suleiman. I'm just going to explain briefly, even though I realise you're the first person making it along, Suleiman. Well, we've got Melissa coming along too now, but this is so how it works, even though it's just a couple of you, welcome Melissa as well, is in the form of a lecture. So I'm going to pop off your mic for now, but if you've got any questions at any point, Suleiman, please do put it on, and you're more than welcome to ask any questions at any point. And the reason we do it in the form of a lecture is just so because people watch it back on YouTube as well, so people can see the recording of the different skills. But yeah, any question at any point, the same for you as well, Melissa, of course, please do ask. And in fact, I'm very grateful exactly if you do have questions, if you do ask occasionally. So please do.
Yeah, could you send the link to the paper we'll be doing, please?
Okay, so it's not actually a individual paper we're doing tonight, it's individual questions. So you'll see I'm going to share the notes on the screen as I go along, and then everything I do I'm going to be drawing. Can you see the whiteboard on the screen currently? And so you can take screenshots of that or write down notes as you go, whatever works for you. And then equally, this lecture is being recorded as well, just to explain, so you'll be able to watch it back on YouTube as well later if you want. What I will do actually, just for both of you who have come in, is I'm just going to share the link to our YouTube playlist, so you have it. So you can watch on this YouTube playlist, you can watch the first couple of lectures from last week, and as I say, this lecture is also being recorded, and so will be put onto that as well. So I've actually shared two playlists. The first one's that. The second one is the full last run-in of the series. So if you want to jump ahead or look at any topic from a different perspective, anything like that, you can watch them on the second link. All right, brilliant. I hope that's all clear for now. So I'll just explain the first bit again for you two as you just come in. So we're looking at some of the more fiddly areas with algebra in the foundation exam today. So the first thing we're going to look at is factorizing quadratics. And we've got an example of how a quadratic equation looks here. It comes in the form ax squared plus bx plus c. So the fact it has x squared, this is what makes it the quadratic. And to say in the foundation, maths, a will always equal 1, so you're always going to see the equation starting with just x squared. And so, therefore, to factorize a quadratic, in effect, what we do, we put it into double brackets. So we've done earlier in this course, we've done expanding double brackets. This is in effect the opposite of this. So it's putting back equations into double brackets. And there are, within the foundation exam, there are three main types of quadratic you can come across in the foundation exam. And we're just going to look at an example of all three of them now. And how you solve them, regardless of which type it is, it follows quite a similar pattern, but there are three different versions of the signs you come across. So we're going to look at the first type here. Okay. So we've got here, we've got where it contains all positive. So e.g., we've got here x squared plus 5x plus 6 when both, so you can see both parts of our equation, we've got two pluses. And if you have a question with this, it will say something on the lines of factorize fully. It may say factorize the quadratic, but it won't necessarily tell you it's a quadratic. So the first stage of factorizing a quadratic in the foundation exam is always the same. So what we do at the start, we have write out two brackets, put in an x at the start of each. So in the foundation exam, it's always going to be like this. We know it's going to be into double brackets because it's a quadratic we are factorizing. And we can put an x at the start of each. And that's because it's always going to be a equals 1 and x times x equals x squared. And now carrying on from this, because both sides in our quadratic are plus, both signs in the brackets will also be plus. So because they're both in a quadratic, and these are the easiest ones to solve for that reason, we know within our brackets we're going to have a plus and a plus. And then this is basically what you have each time, but it's going to be slightly different what signs and everything each one. So now we need to find two numbers that add to b, so the middle term, or which is 5 in this case, and multiply to c, so the third term, which is 6. And that's because if you think about when we've expanded double brackets previously using the FOIL method, the 5, the midpoint, is always the result of adding the outside and the inside. So we need to add our outside and the inside together to equal this. And our final is always going to be the result of the last and multiplying the last two terms. So it's multiply for this and add for this. Well, in this case, it's relatively straightforward finding the numbers. You may well be able to see it already, but a good way you can do it is just think of factor pairs if you're not sure. So factor pairs of 6, so numbers which multiply to make 6. So you could have 1 times 6, but then if we do 1 plus 6, it equals 7. So we know that's wrong, it can't be that. Or we know also to make 6, we could do 2 times 3, and 2 plus 3 equals 5, which is exactly what we need. So we know it's that. So we can just put our final answer of x plus 2, x plus 3. It doesn't matter which bracket you put the 2 in, which one you put the 3 in, because they're both pluses. So that's our final answer to this question, x plus 2, x plus 3. Now, if you want to double check your answer of a question like this, you could then expand back out the brackets, again using a FOIL method. And assuming everything's correct, you will end up back where you started at x squared plus 5x plus 6. So I'll just give a second in case either of you still need to copy over, and then we're going to move on to our next example. Okay, and at any time, by the way, if you need me to go back to a previous slide or anything like that, please just let me know. It's no problem at all. Okay, welcome Lynn as well. Yeah, I'll just go back for a second. No, no problem. Can you just let me know, Solomon, when you're ready to move on? Okay, all right, brilliant. And yeah, I always try and give a little bit of a warning before I move on as well. So I'm gonna say, if you need me, yeah, exactly. If you need to, you can always take a screenshot as well as you go. But yeah, it's no problem, as I say, when you do need to go back. We're going to move on to our second type now. So we've got subtype B is when a B is negative and C is positive. Right, so I've got a little line down here because we're going to do both on the page. So we're going to copy across a question for this. So we've got here x squared minus 10 plus 21. And again, it would say something like fully factorized, or it could say factorize a quadratic. Obviously, that's then being more generous if they say it this way, because straight away, if you see quadratic, you should be thinking double brackets, but hopefully you'll be able to recognize it with the x squared. Anyway, I just got someone else popping in 1 sec. Okay, welcome Claire as well. All right, so we got factorize again, a quadratic. So just like before, just as before, we write out our double brackets with an x at the beginning of both, because again, in all of these examples in a foundation exam, x is going to equal 1, so it's always going to be the same, always going to be 2 brackets, and then x times x equals x squared. However, now we are going to need to have sort of numbers that add to a negative and multiply to a positive. And so the only way this can happen is with 2 negatives in the brackets. Because remember, multiplication, a negative times the negative is a positive. So that's all we've got to do here. So we can put here, we can put our double brackets out. We have an x at the start of our first one, an x at the start of the second one, and now we can need a minus and a minus. So now, just like before, we need to find 2 numbers that add to 10. Technically, it's add to minus 10, but if the 2 numbers add to 10, they also add to minus 10 if they've got negative signs in front of them, so it's easier to just think of it as add to 10. So we need 2 numbers that add to 10 and multiply to 21. Because again, you've got here the midpoint, if you were expanding brackets, is from the outside and the inside, so it's addition, and the last term is from multiplication. So really it's add to minus 10 and multiply to 21, but it's easier to think of it as just add to 10 and multiply to 21. So we can do down here again, if we do factor pairs of 21, so numbers which multiply together to get to 21, well, you can have 1 times 21, but then obviously 1 plus 21 equals 22, so it definitely does not equal 10 as we want. Now 2's don't go into 21 because it's an odd number, but we can have 3, so we can do 3 times 7, and then 3 plus 7 equals 10. Yeah, equals 10. And so we know that's what we're looking for, because we need numbers that add to 10 by the 21. So just as 3 plus 7 equals 10, minus 3 take 7, so we're in 10 now. Hand and brain obviously not connected. Minus 3 take 7 equals minus 10, because they're mirror numbers of each other. And then negative 3 times negative 7 is going to give us positive 21. So again, when the first sign is minus and the second sign is addition, it's reasonably similar to the first type, but with both addition on it. Okay. Okay, so we're going to move on to the third type now. And so type 3, we've got C is negative. T is negative. Okay, and so I'm going to give an example of a question here. So again, it would say something like factorize fully or factorize the quadratic. Fully. So these are the most tricky, because for the last sign to be negative, and that's for the multiplication, one bracket must be positive and one must be negative. So we've got minus 18. Well, minus 18 is the result of multiplication. So for something to multiply to get a negative, it has to be a positive and a negative. So we can write out our brackets as before. We've got x here, and we've got x here. And because it's x in both, we can write our plus and minus. But because it's like this, well, the process is the same as before. You need to make sure you put the correct number in each bracket. So it's more fiddly now. We've got to make sure we put the correct number in each bracket. So we need to find two numbers which add to positive 3 and but multiply to negative 18. So we've got here, we can do below, just as before, we can do our factor pairs. So we've got factor pairs of negative 18. So what numbers can you multiply together to get negative 18? Well, you could do 1 times negative 18, but if you do 1 take 18, it equals negative 17. So we know that's not going to be it. You could do, equally, you could do negative 1 times 18. Now we sort of know you wouldn't have to write these all out unless you didn't feel confident to, because you know if the number's not correct, it's not going to be it. It's not going to be negative 17, it's not going to be 17. Now, negative 18, you could also multiply by 2. So you could do 2 times minus 9 or minus 2 times 9. Well, 2 take 9 equals minus 7. Negative 2 plus 9 equals 7. But either way, they do not work. So we carry on up. Then we've got 3's and 6. So you could have 6 times minus 3 or minus 6 times 3. Well, 6 times minus 3 equals negative 18, of course, which is what we want. But if you do 6 take 3, it equals 3. And so negative 6 times 3, of course, equals negative 18, as we said. But negative 6 plus 3 equals negative 3. So we're looking at it, we want plus 3. So the one we want is going to be this one here, because 6 take 3 is going to give us the positive 3, which means we need the 6 after the plus and the 3 under the minus. X plus 6, x minus 3. And if you multiplied it all out, you do x times x give you the x squared. You do 6 times x, 6x, x times minus 3x, so that will give you the 3x. And you do 6 times minus 3, which would give you the minus 18. So if you multiply it all out at the end, it's going to give you the correct answer when you get that. It will take you back round to the start. All right, so just give a second more to copy this, and then we will move on. Yeah, just to say as well, because I know you're asking before, Solomon, about a paper. Well, it's not from a paper. The page get some of these notes from is from the MME site, and there's some practice questions on there as well. If you want to carry on having a look at this afterwards, I'll share it there, and you be able to find the other topics from today on the same site as well. But we're just going to show a quick example as well of solving a quadratic through factorization. a quadratic through factorization. So you may be asked to solve a quadratic. To do this through factorization, we follow the exact steps as before. We just have one additional step at the end. And it's worth saying a quadratic always has two answers. So it's always going to have two answers every single time. And whenever it will be written in plural, which can help you in mind, it will always say find the solutions. It won't say find the solution, it will say find the solution. So it's a minor distinguishment, but it's something to keep an eye out for because it can give you a little bit of a reminder. So we'll just look at an example of this. So we've got solve a quadratic equation, x squared minus 3x plus 2 equals 0 by factorization. So you can see it looks like what we had before, but we've just got equals 0 on the other side. Now, a quadratic equation, before you solve it, it always has to equal 0. So if you had this and it said like equal 4, you'd have to take 4 away. It always has to equal 0 in order to solve it. But the first stages we do is just the same as before. We're just going to worry about this part of the question. So we can write out our double brackets. Got an x here and an x there. And then here you can see we've got, in our equation, we've got numbers which add to a negative and multiply to a positive. So it's always add to the first one, multiply to the second one. We'll add to a negative, multiply to a positive. That means our brackets have to have two minus signs. And now we need two numbers which multiply to 2 and add to 3. Well, there only are one factor power of 2. So factor pair of 2. Well, the only way is 1 times 2 is equals 2. Obviously, 1 plus 2 equals 3. So those are our two numbers we're going to have in the brackets. X minus 3. Sorry, I've written it wrong there. X minus 2 and x minus 1. Let's do x minus 1. And so this is where that bit before is exactly the same as what we've done. But now we have factorized the brackets. We can split them into two linear equations that will equal 0. Solve these to find the answers to the quadratic. So what I mean by this is we can, in effect, we can write this out twice. You can put a line, we've got two brackets here, and we can rewrite this out as x minus 2 equals 0, and then as x minus 1 equals 0. Well, these are relatively straightforward equations to solve. If x minus 2 equals 0, well then x must equal 2, because 2 minus 2 equals 0. Effectively what you're doing is you're adding 2 to both sides of the equation. If x minus 1 equals 0, well, effectively you're adding 1 to both sides of the equation to get the x on its own. So x equals 1. So that's your final answer, is x equals 2, x equals 1. And just to show, we can double check we are correct by putting our values into the quadratic. So we could do that where we know x squared minus 3x plus 2 equals 0. So we got first, we got if x equals 2. So then we'd have 2 squared, which gives us 4, minus 3 times 2 plus 2 equals 0. Sure enough, because 2 squared is 4, minus 6 plus 2. And so that equals 0. Or if x equals 1, we can do 1 squared, which gives you 1, minus 3 times 1, which is again going to give you minus 2, plus 2 equals 0. So we can see the equation works with either of our two values. This means we know we are correct. All right, so we'll leave it there for a second. And now for the rest of this class, or at least probably for the rest of it, we're going to move on and have a bit of a look at simultaneous equations. I'll just give a sec to copy and then we'll go there. Okay, so simultaneous equations for me is one of the hardest topics for me, which comes up in the foundation paper. On the bright side, if you can get on top of it, it doesn't change. If you know how to do simultaneous equations, at least at the foundation level of simultaneous equations, then you will know how to do whatever questions put in the exam. But what can make it very challenging as we get to it is in terms of negative numbers and things like that, which can make it very confusing. It really helps with simultaneous equations to be confident in negative numbers, so that you're not worrying about that, so you can focus fully on the equation. So simultaneous equations are two, technically it's two or more, but within the foundation exam it's two, are two equations which share the same variables, both balanced. So like the same value, for example, for x and y. So normally it is written as x as y for a simultaneous equation. And so in these questions, we need to find the value of x and y. Okay, so I'm going to give a first example here, and this is simpler than you will get actually in the exam, but just to explain, sort of show an example, building up to slightly more different ones. So e.g., we've got here, I'm given 2x plus y equals 10 and x plus y equals 4. So to solve a simultaneous equation, we need to arrange that one of the variables is the same in both, and then take one equation from the other. So in this case, one of the variables is already the same in both. Y, we've got 1y in our first equation, we've got 1y in our second. So all we've got to do in this case is take one from the other. So you write one above the other, you could have 2x plus y equals 10, and then you can have x plus y equals 4. And so take one from the other, and so we get to x just equals 6. So in this case, it's relatively straightforward because they've given us lovely values here. We don't have to do any rearranging or anything like this. So then once you have the value of one variable or one unknown, you can put it in one of the equations and solve to find the other. So in this case, we know x equals 6. We know x plus y equals 4. So we can rewrite this out as 6 plus y equals 4. And then we rearrange the equation. We want to get the y on its own. So we need to take away 6 from both sides of the equation. Remember, from solving equations, whatever you do to one side of the equation, you have to do exactly the same to the other side. That's just going to give us y equals -2. And so that's our final answer, is x equals 6, y equals -2. And if we put in the other equation, 2 times 6 is 12, plus -2, which is the same as take 2, equals 10. All right, so we're going to look now at a slightly more exam style one of these questions, or a sort of thing you will come across. And this is definitely more challenging. The logic between what you have to do stays the same, but you've just got extra stages to get that. So we've got find the solution to the following simultaneous equation. Now we've got 4x plus 3 equals 14, 5x plus 7y equals 11. So we're still going to write them one on top of the other as we did before. And so I'd always present these. We've got 4x plus 3y equals 14. And then we've got 5x plus 7y equals 11. And so basically, if you multiply both sides of an equation by the same amount, it still balances. So like, for example, if you had an equation which says x equals 2 and you multiply both sides by 2, then you get to 2x equals 4. It wouldn't have changed the value of x at all at that stage. So if you multiply both sides of an equation by the same amount, it still balances. We need to make one of our variables, say either x or y, the same. We do this by finding a common multiple of x or y. And the way we can do this is just like the maths we've done, or we do when you are adding or subtracting fractions. So when you add or subtract fractions, you have to find a common denominator. And you can do this, either one denominator will go into the other, or if not, you multiply the denominators together. And it's exactly the same what we do here. Well, if either of one of like our x's or y's went into the other one, we wouldn't have to multiply both. We could just change the one which was lower. But if not, to find a common multiple of 4 and 5, what you do is you multiply them together. And so what that means in effect is we are going to multiply our entire top equation by 5, and we are going to multiply our entire bottom equation by 4, because we've got to multiply every single part. So we can't change one part of an equation and not the other, because it's like scales. We'll make our equation not balance anymore. We'll change the value of our variables. So we've got 4x times 5, and that gives us 20x. We have got then 3y times 5, which gives us 15y. And we've got 14 times 5, which gives us 70. All right, and then we can do on the bottom, we can do 5x times 4, which again is the reason we're doing it. We are making our x's the same. We've got 20x. We've got 7y times 4, which is going to give us 28y. And we've got 11 times 4, which gives us 44. So now we've done this, now as before, now we take one equation from the other. And it doesn't matter which equation you put on the top, which you put on the bottom. Sometimes one will be easier than the other. Here I would say they're much the same. I'm going to do it over here on the side, but we've got 20x plus 15y equals 70. And we are going to minus 20x plus 28y equals 44. Okay, so 20x minus 20x, well, the entire reason we've done this, we want to get rid of one of our variables. They cancel each other out, equals 0. Then we can do 15 minus 28. And whenever you're doing like a bigger number take smaller, it's just finding a gap between the two numbers. It's going to be a negative because we're taking a bigger number than a smaller, but you can do 28 take 15 gives us 13y, and then just add in a negative. It's the easiest way to do it. And then we've got 70 take 44, which is going to give us 26. All right. So now we've done this. Now we divide 26 by the amount of y's, so negative 13. So again, effectively now we're just solving an equation, just like you do at the end when you're solving an equation, you divide by the amount. Because we've got more than one, we need to do that stage here. So we need to do 26 divided by minus 13. So y equals 26 divided by minus 13, which equals negative 2. So remember, just like with multiplication, a positive divided by a negative gives us a negative. 26 divided by 13 equals 2. It's negative 13, so it's negative 2. And now, just as before, now we put our value into one of the original equations and solve. Okay, so we've got that here. We can do minus 2. We'll let this equation slightly simpler, so we're going to select this one. So we've got 4x plus, and then 3y, so it's 3 times negative 2. I've written it in brackets just to make it simpler to see. Technically, because of big maths, the multiplication is before the addition anyway, equals 14. Well, 3 times negative 2 gives us negative 6. So we've got 4x plus negative 6 equals 14. And if you're adding a negative, you're actually taking away. So you can rewrite out as 4x take 6 equals 14. Then we can add the 6 to both sides. So you can say 4x equals 20. Divide by the amount of x's, divide by 4. And so x equals 5. So final answer is x equals 5, y equals minus 2. And if you put into either of the original equations, 4 times 5 is 20, plus 3 times minus 2 equals 14. 5 times 5 is 25, plus 7 times minus 2, take away 14 equals 11. So we can see if we put our numbers into the original equations, it's going to work. But it is, as you can see, it's quite a fiddly, fiddly old task, this one. It's not a simple skill to master. It does really take a little bit of practice. There's no magic way around this one. I'm just going to show just another example of a sort of regular question for this. Okay. So we got here, solve the following simultaneous equation, 4x plus y plus 4y equals 56, 2x minus y equals 7. And so in this case, we still need to find a common multiple of one of our variables, so x or y. However, in this case, because 2 goes into 4, and so 4 is a common multiple of 2 and 4, we can simply multiply our second equation by 2. We don't have to touch the top one. We can just multiply our second one by 2. So we got that. We got 2x minus y equals 7. So if we times that by 2, we're going to have 4x minus 2y equals 14. For x minus 2y equals 14. And so now we can do the stages before. Now I should mention, it's not relevant to this one because it's easier to do with the x's anyway, but if you have one variable which is positive and the other that is negative, so say plus 4y, negative y, don't try and make that one the same. It just gets very complicated because you'd have to multiply one equation by a negative and so on. Always make x the same if one of the two y's is negative. All right, we're going to rewrite this out below. Now we have altered the second equation. So we've got 4x plus 4y equals 56. And we've got 4x minus 2y equals 14. And so now we need to do our takeaway. Now, again, we've cancelled out our x's, which is exactly what we want to do. But with our y's, we've got to be really, really careful here. This is why it's very easy to get caught out, because really what we are doing is we're doing 4y minus 2y. And so if you're doing minus 2y, these two signs in effect, they cancel each other out because they're both in the middle. So it becomes 4y plus 2y. So 4y minus 2y equals 6y. So be really, really careful with that. It's easy to forget to do that in simultaneous equation questions, to be focused on another area and to miss that key point. All right, and then we got 56 minus 14, well, that's going to give us 42. And now we can just do before, we can divide by the amount of y, so we can divide by 6, and we're just going to get to y equals 7. And so we can put that in either of our original, I can put that in either of our original equations. So we can do here, it doesn't matter which, we'll put in the second one just because it's a bit simpler. So we've got 2x minus 7 equals 7. And so to solve this, we're just going to add 7. That's going to leave us with 2x equals 14. Divide by the amount of x's, so divide by 2, and so x also equals 7. So our final answer is x equals 7, y equals 7. Both in this case equal exactly the same thing. Okay, so I'm just going to show one more type of solving equations, and this is when you've got what's called sort of applied algebra. So in this particular question, you wouldn't be told it is simultaneous equations, but it looks very much like a simultaneous equation question if you look at the information, and you can use this skill to solve. So we're given here, we are told a store sells milkshake and ice cream. 2 milkshakes and 2 ice creams cost £7. 4 milkshakes and 3 ice creams cost £12. Work out the cost of an individual milkshake and ice cream. So to solve this, simply write both products as letters and then write out the simultaneous equation. Okay, so here we got 2 milkshakes and 2 ice creams, so we can put 2m and 2i. We got 4m and 3i, and so we can write this out below. We could say, you could call it x and y if you preferred as well, whatever you feel comfortable with. So we can say 2m plus 2i equals 7. We can also say 4m plus 3i equals 12. And well, 2 is going to 4, so we can just multiply this first equation by 2. And that's going to come to 4m plus 4i equals 14. And we got below 4m plus 3i equals 12. We take one away from the other, so our milkshakes are going to cross themselves out. 4 take 3 is just going to give us an I equals 2. Well, technically speaking, it's ice cream costs £2. Now we can put that into either of our original equations. If we just put in the first one, we can say 2m plus 2 times 2 equals 7. Well, the 2 times 2 gives us 4. So now we can take away the 4. That's going to leave us with 2m equals 3. And so if we divide by 2, we can say that m equals 1.5. Or if we're going to write out in the names of the question, we can say milkshake costs £1.50, because 1.5 is £1.50 or £1.50. So that's your final answer. Ice cream costs £2, milkshake costs £1.50. So it's using what you understand about simultaneous equations and applying them in order to solve a problem. All right. Now I'm just going to quickly show something just for both topics we've done today, just as we've got 5 minutes left, because you occasionally get a slight sort of graph question for this. So sometimes with both quadratics and simultaneous equations, you may be asked to solve them with graphs. This is relatively straightforward as long as you know what you are looking for. So these are sort of questions when you're asked to do this. If you don't know what you're doing, they can look extremely intimidating. They're the sort of questions someone might leave because they look really hard. But in reality, they're not so bad. So this, I've got an example of a graph here for, I'm going to use one I've already got, even though the original question with it's a little bit different, but I'll explain what you normally get. So you'd be asked, for example, e.g., use the below graph to solve the quadratic for where x equals 0. There you go, written on here. I'm sorry, I've written my x equals 0. Forgive me, I should have written my y equals 0. Y equals 0. And so, to solve a question like this, you simply need to read the two values where the line crosses the y axis. And so your answers would just be answer equals -1 and 3. Because that's all it is to it. Now, if you're asked to solve for y equals 1, you would have to draw a straight line through y equals 1, and it would be the 2 points where y equals 1. If you had to do y equals 2, it would be the same. But that's all it's asking you to do. I'm just going to draw, forgive me for this bad graph, it's going to be a little bit of a sketch done very quickly. I apologise, this doesn't have a straight line fixture and I'm not capable of drawing a straight line. And so this is basically a bit of a rough sketch because I don't have an actual question in front of me. We're a bit short on time. But to solve a simultaneous equation using a graph, simply find the value for x and y where the two lines meet. Because a simultaneous equation will be shown by two lines. So it could be, for example, this was, I don't know, 3x plus 2. This was minus 2x plus 6 or something like that. And then the points where they both meet, this will be your answer. And I've seen if they do come up, they tend to come up right at the end of the exam. So it's a good thing to be familiar with because it can be quite a cheap point. All right, well, I'm going to leave it there for tonight. So thanks so much to the four of you for making it along. Really appreciate it. It was certainly a bit of a lonely start this evening, so really grateful you all made it. And yeah, hope you all have a great night. We're back here tomorrow at 7:15 again. So the lectures are going to be 7:15 every Thursday and Friday. And I believe we're looking at numbers tomorrow, some of the topics to do with that, but I'll have to double check. No problem at all. Hope you all have a brilliant night and hopefully see you back here tomorrow. Okay. Bye.
Thanks very much. Thank you.
You're welcome. Bye bye. Good night. Bye bye.